Hello, Algebra 2A, and welcome to Unit number 2, Lesson 3. We're talking about sine, cosine, and tangent today. I am your host, Mr. Rengel, for this lesson, and we'll start with our learning target. So our goal today is to study the properties of trigonometry, specifically sine, cosine, and tangent. By the end of today's lesson, you will know how to find the ratios of sine, cosine, and tangent. And secondly, we will know how to find missing sides of right triangles and missing angles of right triangles using sine, cosine, and tangent ratios. We'll start with a couple of definitions. Trigonometry is the study of angles and sides in triangles. So a lot of different relationships between triangles, angles, and sides that we can start to discover. A trigonometric ratio is a ratio of sides in a right triangle, and trigonometric functions are the sine, cosine, and tangent, and they can describe the relationship of sides and angles in a right triangle. To start out this lesson, we will first identify the sine ratio, cosine ratio, and tangent ratio based on an angle in your right triangle. So we'll use that diagram to the right of the triangle there, and in each case we are looking to find the sine, cosine, and tangent based on angle A. So what I like to do is circle angle A, and then I call that the vantage point. So vantage is a way you're looking at something. So vantage, I know I spelled that wrong, but vantage point, it's the way we're looking at the triangle. So from this position, we are going to start to label our sides. There's 3 sides in a triangle, and we are going to specifically name the sides depending on our vantage point. So first, our hypotenuse, that never changes. It's always the longest side in a right triangle. Next is the adjacent. Adjacent is right next to your angle, and we're going to, throughout the lesson, represent the adjacent side with an A. And then the side opposite is the remaining side, and we're going to represent that throughout the lesson with a letter O. So those are the special sides given from that vantage point of A. So first is the sine. The sine of angle A is the ratio of the length of its blank side to the length of the blank. So the sine, first of all, is the length of the opposite side compared to the hypotenuse. So in every right triangle, the sine ratio represents the opposite side of your angle compared to the hypotenuse. So we're going to represent opposite with a letter O, hypotenuse with H. And in our specific triangle, opposite leg is named BC using geometry, the endpoints of that segment, and the hypotenuse is AB. Next is cosine. Cosine represents the adjacent side compared to the hypotenuse. So in every right triangle, when we're looking from our vantage point, the cosine ratio represents the adjacent, so the side right next to your angle, compared to the hypotenuse. So A over H, which our labeling here would be AC over AB. And lastly, the tangent of our angle would represent the opposite side compared to the adjacent side. So tangent is your opposite compared to adjacent, which in our triangle that's labeled as opposite is BC compared to our adjacent, which is AC. So there would be our 3 trig functions, and it's a lot of information to handle there, but there is an acronym that goes along with this called SOHCAHTOA. So if you can remember that, helps you organize your sides of your right triangle and start to choose, eventually when we start solving these, start to choose which trig function we need to use as we look at our triangle. Our first goal today is just to get comfortable with finding the sine, cosine, and tangent ratios. So we are in problem 1 looking at finding the sine, cosine, and tangent of angle B. So angle B would represent my vantage point, so I'm going to circle that. And then from B, I'm going to start to find and label my sides. So 25 is my hypotenuse, that's the longest side. I always go and find that one first. 24 would represent the side right next to B, that's my adjacent, and then 7 is going to be my opposite. Once we have our sides labeled, we can start to find the ratio of sine, cosine, and tangent. So sine, remember, using our acronym, is the opposite side compared to the hypotenuse. And I look, my opposite side is 7, my hypotenuse is 25, so I just simply write in the values 7 to 25 would be my sine. My cosine is my adjacent compared to my hypotenuse. So I look to find my adjacent, which is 24, compared to my hypotenuse, which is 25. And lastly, my tangent is my opposite over adjacent. My opposite is 7 over my adjacent, which is 24. So those are the 3 ratios that represent the sine, cosine, and tangent of angle B. Now, sine, cosine, and tangent are very helpful when we start to solve right triangles, find missing pieces. And to use sine, cosine, tangent, we need a side that we know, which in this case we know 62, and we need to know an angle. In this case we know that 15 degrees there. We'll start by circling the 15, that represents my vantage point. And then from there we'll label our sides, our hypotenuse, our adjacent, and our opposite. So our right angle is right there. Just assume that's the right angle because that's looking like a right angle. So we've got our vantage point, and then from that vantage point we've got those 3 sides labeled. Now the next thing is kind of going back to some things we talked about back in geometry, so way back. In a right triangle, if you know another angle in a right triangle, in this case we know 15 degrees, that now means that any other right triangle with 15 degrees is going to be similar to this triangle we're working with. And that also then means that all the ratios of sides within that triangle are going to be the same as every other 15-degree right triangle in the whole wide world. And those ratios are actually conveniently saved right into your calculator, so we can use those ratios to help us find the missing sides of our triangles. So here's how we can do that. We start next looking for the labeled sides of our triangle. So we have an x right here that we're trying to find, and we have a 62, which we know. So I'm working with then this adjacent leg, and I'm working with the hypotenuse. So we just got done looking at the 3 ratios, so think back which ratio uses the adjacent and the hypotenuse. If you said cosine, you are correct. The cosine is the trig function that uses the ratio of the adjacent side to the hypotenuse. So to set up our problem using cosine, we are going to take the cosine of our angle, which is 15 degrees, set it equal to the ratio adjacent over hypotenuse, which is 62 over x. Now there are a couple ways to attack this algebraically. I like to get the x out of my denominator, so 62 is divided by x, so we're going to do the inverse, which is times by x on both sides. So we're going to have x cosine 15 degrees equals 62. Then going back and solving for x, we're going to divide by the cosine of 15 degrees and divide by the cosine of 15 degrees. So x was times in cosine of 15, we're going to do the inverse operation, so that's going to cancel that out. Now you're left with, just in your calculator, you're going to take x equals 62 divided by the cosine of 15 degrees. And we'll get x is equal to 64.2. And when you type into your calculator, you get 64.187. We'll round these to the nearest tenth. So 1/8 would round up to 0.2. Now if you tried that in your calculator, you did not get that answer. Here's one little thing you want to make sure that you do. In your calculator, you have to go to mode, which is right next to your second button, And then after mode, when you get into that menu, you're going to go down to where it says radian and degree, and you need to make sure that you change your calculator to degree. So if you got some funky answer when you tried that one, go and check the mode that you're in. You need to make sure your mode is in degree. To finish up with example 3, we'll look at a couple of story problem scenarios where we can use trigonometry. So keep in mind, before we had all of our fancy land surveying technology with lasers and things, that this was a strategy that was used quite a bit to find missing lengths of things that could not be measured directly. So, looking at example 3, part A, a radio signal is sent by a boat to a receiver at the top of a lighthouse. What is the distance traveled by the signal? The lighthouse is 162 feet tall and the angle of elevation is 35 degrees. So if we have our boat over here, I'm going to draw a sailboat. My son always says I'm a really good sailboat drawer, so there it is. And then we're heading to a lighthouse over here, which we'll draw. Up there, we're sending our signal to the top of this lighthouse. Up here is where it's reaching to, and we want to figure out what is the length traveled by the signal. Well, that dashed line I just drew, that represents the length of my signal. Secondly, we know that the lighthouse is 162 feet tall. That would be this measurement right here. Now if you're kind of looking closely, the signal goes to the top here. We can connect back to the boat. And what type of shape are we creating? Yeah, we're just creating a right triangle. Lastly, once we have our right triangle, we can head into finding our angle of elevation, which right in here, our angle of elevation is 35 degrees. That also will represent my vantage point. So my vantage point, I'm going to circle. There it is. The X represents my hypotenuse. This water down here would represent my adjacent leg, and then that means 162 represents my opposite. After I find my 3 sides, I look at the 2 that are labeled, so I'm not going to use adjacent down here. I'm going to use my opposite and my hypotenuse, which in this case is going to be sine. So sine of 35 degrees is going to equal my opposite, 162, divided by x. Now we just did the algebra on the last problem when my x is down in my denominator. And really what happens is these two just change positions. So to find x, x is going to equal 162 divided by the sine of 35 degrees. So in our calculator, we'll take 162 divided by the sine of 35. Once we plug that in, we'll get 282.438, which 4.3 is going to stay the same at 0.4 when we round that to the nearest tenth. So our final answer is x equals 282.4. The last cool thing that we can do with trigonometry, sine, cosine, tangent, is we can use a ratio in a triangle to find an angle measure. So here we have a problem where we know our measurements of the sides of the triangle, but we can use those to find an angle. So here it says a tourist is standing 400 feet away from One World Trade Center in Manhattan. The One World Trade Center stands at 1,776 feet tall. What is the angle of elevation from the tourist's feet to the top of the One World Trade Center? And hint, we're going to use inverse trig functions to find the angle measure. But we'll draw a quick little picture here. So I'm standing right here. The tourist is standing down here. And One World Trade Center is over here. So we'll draw that. with a spire going up the top there. And we want to know what is the angle of elevation from the feet of the person to the top of the One World Trade Center. So we're going to draw an angle of elevation from our feet to the top of that. Now the only other things that I know are the distance I'm standing from the building is 400 feet. And then the height of the building is going to be 1,776. Okay. Now, we don't know what the angle is, but we can still label where that angle would be. The angle we're looking for is this angle right here, which also is going to be my vantage point. So I am going to circle that. So from that vantage point, this would be my hypotenuse. This would be my opposite, and this would be my adjacent. So there would be my triangle labeled based on that vantage point. Looking at my labeled parts, I've got 1776, I've got 400. Based on opposite and adjacent, that tells me I'm going to use tangent. But whenever we're finding angles, we are going to use the inverse of tangent. So in your calculator, what you're going to look for is if you look above tangent, you should see a little tangent to the -1. To do that, to get that function, you got to hit second tangent, and that should pop up a tangent -1, which is called tangent inverse. And once you have the tangent inverse, you can put in your ratio. So opposite over adjacent, we're going to put in 1,776 over 400. Once we do that, we will start to find out our angle measure. X is equal to 77 degrees. So to get an angle measure, to find an angle measure, I'm going to use my inverse functions to find those angle measures. Thank you for joining me today. This has been Mr. Rengel. We worked on our learning targets of identifying the sine, cosine, and tangent ratio. Secondly, we found missing sides using sine, cosine, tangent. Then lastly, we found missing angles using sine, cosine, tangent. So good luck and hope to see you soon. Mr. Rengel signing off.